Welcome back. Now we're going to talk about integrals of vector-valued functions, as well as projectile motion. So we're going to start with our indefinite integral definition. So the indefinite integral of r, some vector, with respect to time t, is the set of all antiderivatives of r. So that's denoted by the integral of r of t dt. So capital R represents the antiderivative. And this should look really familiar to our indefinite integral definition or our antiderivative definition that we learned in Calc 1. We're just going to take that now and apply it to vectors. All right, so the integral of some vector little r with respect to t is going to be capital R with respect to t plus some constant c. So let's just look at a brief example. So we're going to look at integrating a vector here. So we have the integrand, cosine of t times I, plus 1 times j, minus 2t times k, integrated with respect to t. Essentially, all we need to do here are integrate each of these component functions. Formally, if we were working this out, we would keep in mind that the integral of a sum is the sum of the integrals. So I'm going to write this out, and I don't expect you to do this every time, but just to kind of help facilitate your understanding and using quite a few properties of integrals, but this would become the integral of cosine t dt times the vector I, plus the integral of dt, all of that, times the vector j, minus the integral of 2t dt times the vector k. So the integral of each of these terms, well, the integral of cosine is sine. It's an indefinite integral, so integral of cosine sine of t, we have plus some constant. Since I know I'm going to have multiple, I'm going to write c sub 1. The integral of dt, that's going to become t plus another constant, arbitrary, c sub 2 times j, minus, and the integral of 2t is, we have t squared plus c sub 3 k. So simplifying this just a little bit, we have sine of t I, oops, I left some of my vector notation off, plus t times the vector j, and then minus t squared times the vector k. And then we're left with plus c sub 1 plus c sub 2 plus c sub 3. And of course, I don't need to write all of those because the sum of 3 arbitrary constants is just another arbitrary constant. So I'll say plus c, and I'll put an addendum over here that says c equals the sum of c sub 1 plus c sub 2 plus c sub 3. So essentially all you're going to do is integrate the component function for each term in your vector. Let's look at a definite integral next. Definite integrals for vector value functions are also best defined in terms of components. So again, if we have r in terms of each of its component pieces on a closed interval, so that when we are taking that definite integral on our bounds from a to b, lower and upper bounds, essentially we're just going to integrate each of those component functions. So let's look at calculating a definite integral of a vector. So here we have a definite integral, and the definite integral that we're working with is the same integral that we just did the indefinite integral. We've just added the bounds from 0 to pi. So again, working this out, I'll rewrite this. This is the same as 0 to pi of cosine t dt times my vector I, plus the integral from 0 to pi of dt times my vector j, minus the integral from 0 to pi of 2t dt times my vector k. So the integral of cosine, we know that is sine of t from pi to 0 times I. The integral of dt is just going to be t, evaluated from pi to 0 for j, and then minus t squared from pi to 0, k. So simplifying this, our first term we end up with there, I have sine of pi minus sine of 0 I plus pi minus 0 j minus pi squared minus 0 squared k. So sine of pi is 0 and sine of 0 is 0, so that leaves me with 0 I. I have positive pi times j, and then minus pi squared times k. So this can be written more simply as just pi j minus pi squared k, or rather we could factor a pi out because we're always looking to factor pi times, that would give us j minus pi k. Either of those are okay. So this video, brief, but it concludes for us how to take the integral definite or indefinite of a vector.